A very warm welcome, everyone. My name's Captain Barry Sadler, and welcome to the latest edition of our podcast. Today I'm going to be discussing some upcoming changes to the IMSBC code that are due to come into force on the 1st of January 2025. The International Maritime Solid Bulk Cargo Code sets out the mandatory standards for the carriage of solid bulk cargoes. It's important to recognise that this code is essential for preventing accidents at sea relating to the transport of solid bulk materials. These accidents could be effects from the liquidation of cargo, cargoes with chemical reactions, cargoes that may cause damage to the ship. The latest amendments, which are due to come into force on the 1st of January 2025, include updated provisions to basically enhance the safety of ships and crews. These amendments address issues like cargo classification, documentation, and of course the procedures for safe handling. The upcoming amendments, as I say, are effective from January the 1st and are likely to introduce new cargo entries and update existing cargo entries in the IMSBC code itself. These changes of course ensure that the code remains relevant and continues to provide guidance on the safe transport of solid bulk cargoes. There are changes to two cargoes of which are of particular note. The two cargoes that I'm talking about are direct reduced iron and electric arc furnace dust. Let's talk about what these cargoes are first of all. Direct reduced iron is a type of iron produced from iron ore through a process called direct reduction. In this method, the iron ore is reduced in its solid state using a reducing gas or elemental carbon rather than being melted in a blast furnace. The result of this is a porous sponge-like form of iron with a very high iron content. DRI is used as a raw material in steel making, particularly in electric arc furnaces, because of its purity and uniform composition. It's often favoured really for its lower impurities compared to that of scrap steel. Electric arc furnace dust, or EAF dust, is a byproduct generated during the steel making process in electric arc furnaces. When steel scrap is melted in the furnace, dust and fumes are produced, which are then captured by the furnace's filtration system. This dust contains various metals and oxides including iron, zinc, lead and cadmium, making it a hazardous waste. However, EAF dust can also be processed to recover valuable metals, especially zinc, making it an important material for recycling in the steel industry. This is why electric arc furnace dust is transported, because many of you may be wondering why would we put that on a ship in the first place. Now there are lots of dangers with electric arc furnace dust, which we'll deal with first. It's toxic, so the heavy metals in EAF dust can be toxic if they're inhaled or ingested, which of course would lead to serious health issues, can cause neurological damage, kidney damage, and of course respiratory problems if they're inhaled. They can cause environmental impacts if they're not properly managed, can contaminate soil and of course water, posing risks to various ecosystems within these. EAF dust can be reactive, which could potentially lead to fire or explosion hazards under certain conditions, and it has been known to self-heat a little bit like coal. Now, direct reduced iron also contains well-documented risks of overheating, fire and explosion, which are associated with the carriage of this cargo. The new cargo schedules within the IMSBC code acknowledge the increased amount of times that these cargoes are being transported and puts in place the necessary measures to ensure that the cargoes can safely be carried. These cargoes are an update to the IMSBC code's list of cargoes, and electric arc furnace dust is a newly listed dry cargo within the IMSBC code. It is important to recognise that because both these cargoes, so both direct reduced iron and electric arc furnace dust, because they both have chemical properties which create reactivity, which can encourage them to burn off their own accord, and in particular can encourage them to give off large amounts of heat which can cause structural damage to the ship. Because of these chemical reactive properties, they then become dangerous goods, and carriage of both direct reduced iron and electric arc furnace dust can only be carried on bulk carriers that hold an IMDG code document of compliance. They would be one of the cargoes listed on the DOC along with the cargo carriage requirements. It's always worth bearing in mind that a bulk carrier that carries cargoes like this does have to comply with the IMDG code. The chemical properties of these cargoes place them in both the IMDG code and the IMSBC code, and compliance with the requirements of both those codes are necessary for the cargoes to be covered safely, for the cargoes to be covered in a compliant way. When ships load both of these cargoes, they must ensure that chemical reactions have not already taken place and that the cargo isn't steaming or excessively hot when it's loaded. If this is the case, then actually the physical loading of the cargo can introduce oxygen into the centre of the cargo and cause the process of self-heating to accelerate. This would mean that on completion of the load, the self-heating process may well be underway, and this can, of course, cause great harm to the ship if it's left unchecked. Like a lot of other self-heating cargoes, the way to combat it is to reduce the amount of oxygen that are going in, which is going to reduce the reactivity that the chemicals have within both of these cargoes. The easiest way to do this is that if the hold temperatures are observed to rise, that all the ventilation to the hold is shut down and that the hold is allowed to use up all the oxygen within it in order to suppress the chemical reaction. The temperatures should be continued to be monitored to ensure that they continue to fall. If the temperatures don't continue to fall, then it may be that the chemical reaction process has caused the cargo to actually ignite and start to burn, in which case you may need to introduce a fixed firefighting method in order to suppress this ignition, and that would normally mean the introduction of CO2 into the hold space. Whether you introduce CO2 or not, or whether you just shut down the hold so that the oxygen is used up in the self-heating process, stopping it, it leaves the hold atmosphere potentially hazardous. It makes the hold a dangerous space, and therefore entry in it after such an event can only be done once we have done a full risk assessment and completed a permit for entry into an enclosed space. The ventilation of the hold, in order to bring the gas levels to that's acceptable prior to entry, would mean introducing oxygen. And so, unless we are confident that the reaction process has stopped through the methods that we have used, we must be very, very cautious introducing oxygen into the hold and encouraging the process to continue. Thanks for listening to this podcast, which has dealt with the latest changes to the IMSBC code. As of today, the 5th of December, they're not in force, but they will be on the 1st of January 2025, and I suspect they will start to come up during MCA examinations.